Molecular crowding creates traffic jams of kinesin motors and microtubules. By Leduc and Friends, PNAS, 2011.
Hi, I'm Ronnie Maroon, coming to you from MTO Center News Station. Today we'll be talking about microtubule traffic congestion, getting really bad. So now we'll get a closer look with our correspondent, Dr. Parmigiani.
Alright, so here we're looking at the traffic coming along the plus-in directed lane, and as you can see, we've got cars coming in on the K-on ramp, cars leaving the K-off ramp here, and we've got a really big traffic jam, a slow velocity, high density traffic jam going on. It's all, you got this guy here at the end who could be dissociating, but he's not, you know the type. Hey, move it, knucklehead! Yeah, look, and now the next guy's stuck there. Hey, what is it about these KIP 3 motors? They always get stuck at the plus end.
Dr. Parmigiani, get control of yourself down there. This is a professional news station. But can you tell me what's actually going on? Is there just too high of a density of cars out there on the road?
So yeah, we got a pretty big pile up here, starting at the plus end and going out along the microtubule. And this is a pretty high density of kinesins. We think this is because there are too many kinesins using the K-on ramps and not as many kinesins using the K-off ramps. I mean, look at that there, it's the Popeyes. So we're pretty perplexed here by the traffic problems out there on the microtubules today. So for analysis of how to solve this problem, we're going to go to Dr. Sumia Mukherjee.
Thank you, Dr. Parmigiani. So what we think is going on is that the K-on is just too damn high. There are too many people on the road. Get off the road and use public transport, people. Or the K-off is too low. Not enough people going to that delicious Popeyes out there. Remember, people, Popeyes is good chicken.
Well, looks like some of these people took your advice there. We got some more people using the K-off ramp. It seems to be clearing up a little bit of the jam here.
Oh, Dr. Parmigiani, I see that some of the traffic's been alleviated, but there seems to still be that one guy just sitting down there clogging everything up at the end. What's going on down there now?
That is kind of a pickle. I mean, now that there are more kinesins using the K-off ramps, which is really good, seems to have alleviated a little bit of the jam here. But there's still, it looks like there's still the jam, the rest of the jam that's building up from that guy sitting there on the plus end.
Of course it is! If only this guy would get off, everybody could move. Get off the end, people!
So it seems like Dr. Mukherjee's really had his influence on that traffic. First he got that density out of there by increasing that K off, and then he went there throwing cars, getting that K end up and decreasing the traffic that way. So he solved both the bottleneck and the density dependent traffic jams. Traffic's looking really good down there now since we took care of that bottleneck and the density traffic jams. But what happens if we have even longer microtubules? Will that cause an even bigger issue?
That's a good point there. A longer microtubule, you're going to have more K-on ramps, so you're going to have more kinesins entering. And as we've seen, these kinesins are pretty processive. They really don't want to use those K-off ramps. So I think for a long microtubule, you're going to have potentially a lot of density problems, especially if you've got a lot of K-on ramps. And look at this here, we've got a whole bunch of cars just piled up. I suspect this wouldn't be so much of a problem if there are only fewer K-on ramps, especially compared to this just one K-off ramp here. But, yeah, in this case we seem to be pretty stymied. Big traffic jams going on. Pretty ugly situation.
Okay. Parmigiani, that model seems to be working really nicely, but what's actually going on in the cell?
Yeah, that's a good point. So in the cell, we don't have Dr. Mukherjee's fancy tricks to play with the K-end or the K-off parameters, and there's no Popeyes to really entice them to choose the K-off pathway. So we really do have something more complicated going on here.
So you're saying there's no Popeyes or Dr. Mukherjee in the cells? So how do they actually solve this problem? Is it just always traffic jams?
Now, I wouldn't say there are always traffic jams in cells. Come to think of it, we've only been talking about one kind of motor here. Suppose we have another motor, like a Kinesin 1. That has less processivity, so that means that it's going to spend, it's going to use the K-on ramps a little bit less, and it's going to use the K-off ramps probably a bit more than the KIP3s that we've been looking at. So perhaps it clears up its own jams that way. And then, yeah, even the KIP3s that we've been looking at, those are Kinesin 8s. So those might even, seem to have a long processive time, and they also don't seem to leave the in very often. So those might jam up a whole bunch. But in vivo, we think they might also be disassembling the end of the microtubule. So that's going to take a long microtubule, turn it into a short microtubule, and that's going to solve some of your problems for you. Yeah, so it might not even be so clear-cut as just jam or no jam. I mean, even when Dr. Mukherjee was messing around with things, we did sometimes see that there would be one motor at the end of the microtubule. It's still pretty low density across the whole thing, so just having that little density spike there at the end might not be so terrible after all. It might not do horrible things for congestion within the cell. And so, I guess we've looked at a couple different ways in which these horrible traffic jams could have been created, and a couple ways to solve them. And of course, as always, we suggest that motor proteins use alternative forms of transportation.
Diffusion!
Action.
Wow, riveting stuff. I think we've all learned a little something about microtubule trafficking today. And as always, cell biology, stay classy.